morning students. Jai Swaminarayan. In the last lecture, we have discussed up to simple statement and compound statement. Let us discuss these definitions once again, and then students we will start the remaining questions of exercise 14.2. Now students, what is a simple statement? Suppose I write in statement P, pi is a complex number. Now students, this statement cannot be further broken down into two or more statements. This statement cannot be further broken down into two or more statements. A statement which cannot be further broken down into two or more statements is called a simple statement. Then what is a compound statement? Say I write Q, 2 and 4 are factors of 2. So I can break this into component statement like this. Say I, 2 is a factor of 12, and say S, 4 is a factor of 12. So a statement which can be further broken down into two or more statements is called a compound statement, or I can put it in other words like this: a statement which can be broken down into two or more simple statements is called a compound statement. So this one, students, I think all of you have perfectly understood. Now students, based on this, today we will be doing further the sums of exercise 14.2. I think in the last lecture we have done up to the first sum. Now students, we will be doing the further sums of exercise 14.2. Now students, first sum we have already done, so this is second sum, exercise 14.2. Are the following pairs of statements negation of each other? That we have to check. The first statement, the number x is not a rational number. Okay students, exercise 14.2, question 2, part 1, given statement, number x is not a rational number. This is the given statement. Number x is not a rational number. The number x is not a rational number. So the number x is not a rational number means you can say the negation of this. What is negation of this? Negation of p, number x is a rational number. So students, here we are given a pair of statements and we have to check whether this pair are negation of each other or not. What is the given statement? The number x is not an irrational number. Number x is not an irrational number. It means the same. If it is not an irrational number, it is a irrational number. So we can definitely say, students, the given pair of statements are mutually negations of each other. Technically, the negation of the given statement P is number x is a rational number, but I can write the same statement as number x is not an irrational number, means it is a rational number. Therefore, given pairs are negations of each other. Therefore, given pair of statement are negations of each other. This one, students, we have to check. Now let us check the second pair. Now what is the statement? The number x is a rational number. The given statement Q, the number x is a rational number. What is negation of Q? The number x is not a rational number. Now what is given? The number x is an irrational number. Not a rational number means x is an irrational number. So it is one and the same. Therefore, given pair of statements are negations of each other. That one, students, we have to check. Why I am writing, students, so that we can get a better idea of this. So, students, this is a very interesting chapter. This chapter has formulas which are very interesting. Yesterday we had discussed what is the statement, what is negation of a statement. So those things we need to, students, revise again and again. What is negation of a statement? The denial of the truth value of a given statement is called negation of a statement. Means if the given statement is true, then its negation is false, and vice versa. If the given statement is false, then, students, its negation is true. So a sentence becomes a statement in mathematics if we can say definitely universal it is true, or universal it is false but not true, and false at a time, but not true and false at a time. So if a statement is partially true, or true in some cases and false in some cases, then it is not a logically, mathematically valid statement. So it becomes a sentence. This is what, students, we have to remember and memorize. Now, students, our question number 3. Find the component statements of the following compound statement and check whether they are true or false. Number 3 is prime or it is odd. Say, students, question 3, part 1, given statement is number 3 is prime or number 3 is prime or it is odd. Now, students, this is the compound statement. Always remember, students, a compound statement in mathematical reasoning or logic is characterized by and oblique or. Generally, a compound statement will have either of these two words, and or. Here is also a little capital. Now, what are the component statements of this? I call component statement as Q and R. number 3 is prime. Definitely 3 is a prime number. The first natural prime number is 2 and 3. The first natural prime number is 2, then the second is 3. And number 3 is odd also. So component Q is 2. Number 3 is odd. So this is also true. 3 is definitely a prime. 3 is definitely odd. So P and Q both are true. Second, all integers are positive or negative. Second, so the statement is P. All integers are positive or negative. Here the statement P is true. Now the component statement Q, all integers are positive. This is definitely false. Integers can be negative also, including 0. Then are all integers are negative. This is also false. Neither all integers are positive, students. Neither all integers are negative. Integers are positive, negative, including 0. Integers are positive, negative, including 0. So these students we have to perfectly monitor and understand. Now students, compound statement is always characterized by and or. The third statement I am not writing, but I am, you can say, discussing orally. What is given? 100 is divisible by 3, 11 and 5. Here the statement is written like this: P 100 is divisible by 3, 11 and 5. So here our compound statement, students, is involving and. The first two compound statements were involving or. Always remember, students, a compound statement either involves and or, oblique or, I should say. So here the component statements will be like this. First, okay, let me write Q. 100 is divisible by 3, definitely false. 100 is divisible by 11, definitely false. S 100 is divisible by 5, definitely true. Q, R are false, S is true. So the total statement is false. The compound statement will be false. Here the compound statement is false and here the compound statement is true. So depending upon the truth values of component statement, we have to decide the truth value of compound statement. That was, you can say here, find the component statement of the following compound statement and check whether they are true or false. We are not asked, students, whether the compound statement is true or false. So here, students, this is asked. So a compound statement has and, oblique, or. This one, students, we remember here, and this completes our exercise, students, 14.2. Now let us start the concept of 14.3. Now, students, we have to start the concept of 14.3, and for that we have to study logical primitives. That is very important, students. That is the most important criteria. Logical connectives. Logical connectives. Now, all of you students pay attention. This is the core concept of the chapter. There are two logical connectives. First is and students, the other is or. The two basic logical connectives are students and or. Now students, let us understand this with the help of an example. Say, statement P, I write 2 and 5 are prime natural numbers. Now if I break this into components, so let me call this as R and components I am calling as PQ. 2 is a prime natural number, of course. 5 is a prime natural number. P is true, Q is true, so the component statement R is also true. Now students, in logic, we usually have two logical connectives. First is and second is or. So R is written as E and this symbol is read as and. Inverted V students is read as and. So basically students, there are two logical connectives. First is and, second is or. If I join two simple statements by logical connective and that compound statement is denoted by R, then R is written as students P and Q. R is written as students P and Q. Now students, a statement, whether it is simple or compound, has two possible truth values, either true or false. A statement, let it be simple or compound or any type of statement, it has possible two truth values, either true or false. Now students, I am going to define something different not given in textbook, and that is truth table. This is very interesting. And in JW main, students, truth table always follows an integral part of sums. Coincidentally, our textbook has not given the concept of truth table, but students in JW mains, in advanced this is not there in syllabus. Students in JW mains, truth table is a very important criteria. So students, what is a truth table? A table showing possible truth values of component statement and compound statement is called a truth table. Write this definition in textbook with a pencil afterwards. Pay attention. A table which is showing the truth values of component statements and compound statement is called a truth table. Say our compound statement has two component statements which are P and Q. So I am preparing the truth table like this, where component statements are P, Q and compound statement is P and Q, or even I can let R is, you can say, a compound statement joining simple statements P, Q with N. Now one statement has two possible truth values, either true or false, and two statements collectively will have four possibilities. Check. Either both are true, P is true, Q is false, P is false, Q is true, or both are false. These are the possible four truth values for component statements P and Q. We don't have fifth possibility. Check. First possibility, either both are true. Second possibility, either both are false. Third possibility, P is true, Q is false. Fourth possibility, P is false and Q is true. In end, this confirmed statement is true provided both the component statements are true. In remaining three cases, the compound statement is considered false. So, you have to remember these truth tables. And based on truth table, students will be doing some Boolean algebra in physics and logic gates also in physics. So this is directly a very important topic, students, for physics also. I repeat, this is indirectly, students, a very important topic for physics. So if a compound statement has two component statements, possible truth values will be 2 squares of 4. Then if a compound statement has three component statements, possible truth values are 8. And if a compound statement has four component statements, then possible truth values are 2:4, and that is 16. So students, this is what we have to memorize. MCQ asked in JDB, a compound statement P has 10 component statements. What are the possible truth values? 2:10, and that is 1024. As here we have four possibilities like that. If my component statements are 10, then the possible truth values available in the truth table are 2:10, and that is, students, 1024. So logical connectives are basically two. First is and, second is or. This truth table is very important. Write this in textbook. In textbook they have given this in words. But rather than to remember this in words, it is easy to remember in the form of table. In and, if all the component statements are true, then only compound statement is true. In remaining all cases, the compound statement is false. This is what, students, we have to remember. Now students, the second logical connective is or. Say I write a statement T. I write a statement. Let us write a compound statement connecting or. Let us say that 3 is a prime number or 8 is odd. So now, students, I am taking a compound statement involving logical connective or. What I have done, students, I am taking a compound statement involving logical connective or. Let us part this into component statements. P. 3 is the prime number, definitely true. Q. 3 is an odd number, definitely true. So this is, you can say T is equal to P or Q. This symbol V is read as odd. Then inverted V, students, is read as N. So this all quotations are not given, students, in textbook. That is why I am stressing upon, students, this notation. These notations are not given in textbook. Again, if I want to prepare truth table of OR, then like this students. P, Q, T is equal to P or Q, T, 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 F, F, T, F, F, T, 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 F. Students, OR is true if either one component statement or both the component statements are true. If P and Q both are true, then the compound statement P or Q is definitely true. This statement T, small t, is true. Because the components P and Q both are true. Even if one of the component is true, then also the compound statement is true. The compound statement is false provided both the component statement are false. The compound statement is true if both the component statements are true or one of the component statement is true, and you can say the compound statement is false when both the component statements are false. This is what students we have to remember. This is what students we have to perfectly remember and memorize. So in short, we have two logical connectives. This is the topic which I am taking from JEE Mains point of view. The first logical connective, student, is AND. The second logical connective is OR. The truth table means a table which has possible truth values of component statements and compound statements. A truth table, students, note down this definition afterwards in the textbook. A truth table is a table showing truth values of component statements and compound statement. If the component statement are 2, possible truth values are 4. 3, then possible truth values are 8. 4, then possible truth values are 16. You will not have more than 4 component statements of any compound statement in